Unit 4, time value of money. So by the time we are done with this course, we should be able to understand that time is money. And for that, it must be treated with the value it deserves. So time will earn or accrue interest depending on the elements involved. So we understand what is interest, what is simple interest, what is amortized loan, what is to compound. So interest can either be simple or compound interest. So simple interest is interest paid on the original amount or lent. Compound interest is interest on the previous accumulated value. So simple interest formula is given by PTR. So if you have, for instance, 1,000 at 7% simple interest in 2 years, what is the interest value? PTR. So P is 1,000, time is 2 years, and R is 7%. So your interest is 140 kwacha or dollars. So the future value is the initial amount you started with, 1,000 plus 140 to get 100, 1,040. So this is now the future value under simple interest. We also have compound interest where you compound on the previous amount that you had. So it is given by future value is equal to present value 1 plus R at the power time. So we want to calculate the same amount using the future value formula. So using the formula here of a single deposit, 1 plus R at the power time. So we have for the first year you make 1070. For the second year, it is 10% of the 1070. You're going to have 1144. So in the initial we had 140, now we have 144.90. So we have an extra $4.9 compared to simple interest. So compound interest earns you more money. All right. So in a nutshell, this is now the beginning of our computation. So future value is given by this formula that we must know. Future value is given by present value 1 plus R to the power time. Now this is the formula that you can manipulate to coming up with 19 other formulas, including the annuity formulas. So present value is equal to what? 1 plus R to the power time. This is if you're compounding once a year annually. So compoundings can either be once, twice, 4 times, 12 times, 52 times, 365 times, depending on what compounding you are looking at. So one is what? Annually. Twice is semi-annually. 4 times is quarterly. 12 times is monthly, a year. Weekly is 52 times. Daily, it is 365 times. So if it's compounded more than once, the formula that we use is future value is equal to present value 1 plus R over time over the number of compoundings, then MT. So if we're told that we have a present value, I don't have my calculator now, please be quick to calculating. If you have 1,000 kwacha as our principal, and this principal is to be um, invested for 4 years at 8% compound interest. Calculate the future value after 4 years if compounded annually, semi-annually, and quarterly. So future value for annually, we use formula 1. What is our present value? 1,000. What is our error? 8%. 1 plus 0.08 to the power 4 years. So the power 4 years. So what are you getting? 1,000 times 1.08 to the power 4. What do we get?
One, I don't know if I've calculated properly.
I have
1,000.6.
1,360.
13 what?
1360.5.
13.6.5 what?
You can say 0.49 or 0.5.
Okay. 0.50. This is when annually. All right. How about semi-annually? What do we do? The idea is that the interest rates are divided by what? The compoundings. The times are multiplied by the what? Compoundings. Okay. So what is the future value? If compounded semi-annually, what's the effect here? So the 8% be divided by what? By
We
2.
divide it by
Oh.
2,
Then the 4 will be multiplied by what?
multiplied by 2.
2. So what are we going to have? 1,000 times what? 1.0 what? 04. The power what? 8. So what do we get? So the idea here is that the more you compound, the higher the figure. All right?
I have 1,369 or 0.57.
1369.57. Okay. Okay.
Sorry,
Quarterly,
it's supposed to be 1,368.57.
68.57. Okay. All right. So this is compounded semi-annually. Quarterly, you just put a 4 here and a 4 there. Then they also ask you to find the effective annual rate. This is the real interest rate that is earned. It has no aspect of time. So it's given by 1 plus R over M to the power M minus 1. So let's calculate the effective annual rate for this particular detail. So what are we going to do? If it's compounded quarterly, we're going to say what? 1 plus 8%, so 0.08. So quarterly, what am I putting there?
4
4
over 4.
to the power what? 4 minus 1. So this will be what? 1.02 to the power 4 minus 1. What do we get?
Sorry, Collins, my network was bad. You're saying what is AAR?
The effective annual rate.
Okay, thank you.
Mm.
I have 0.082. Don't know how many decimal places we're rounding off to.
So 8.2%, right?
Yes.
So it has increased from 8% to 8.02%. So this is our effective annual rate. Okay, effective annual rate. So we also may be asked to say how long can the 1,000 kwacha, how long can the 1,000 kwacha grow to 2,000 at an interest rate of 8%? How long can 1,000 kwacha grow from 1,000 to 2,000 at an interest rate of 8% compounded annually? What are they looking for?
Future value.
How long is what?
The time element.
The time element, correct. So using this, if it's annual, we use the same formula here. So 2,000 is got what? 1,000. 1.08 to the power time. We don't have time, right? So how do we find the time?
Can I try?
Yes, you can try.
Okay, so I think from where you've indicated the 2,000 is equal to 1,000, in brackets 1.08 to the power t, you start by eliminating or dividing over 1,000 on both sides.
Mm-hmm.
And once you've done that, on our my left side, when you divide 1,000 into 2,000, you are basically left with 2, which is equal to in brackets or 1.08 the power t, where now with the t you multiply it by 1 over t on both sides.
Okay, you introduce logs. The t can only drop when you introduce logs or natural log
Okay.
ln. Okay, but even 1 over t, it'll be difficult to compute that on a calculator. But you've tried. You only do 1 over t if you're
Okay.
looking for the what? So the t will fall in front here. So meaning you need to
Okay.
divide both sides log 1.08. So 1.08 on both sides, what are you getting?
9.006.
9.006. Okay. So it will take 9 years. All right.
Hi, sorry to take you back. How do you compute your logs on the calculator?
Just check there at the far end on top of the AC there is log, something looking LG or log.
Yes,
So,
I've seen the log
so divide
symbol.
log 2 divided by log 1.08. What are you getting?
Log 2 divide log 1.08, which is 9.006.
Mm-hmm.
Okay. All right. Thank you.
All right. So now let's look at
Sorry, I missed it there. How do we calculate the log on the calculator?
how do you calculate the log on the calculator? You press log 2. The log is just above the AC button there. Log 2 over log 1.08. Okay. Are you able to see the log?
Yes.
Yeah. So you get that answer.
Finding 9.006.
Yes, 9 points. So 9 years.
Okay,
Yeah.
okay.
Okay, so we can proceed to time. If we're given the time, but we don't have the what? The interest. So what rate is required for 1,000 to triple in 4 years? What rate is required for 1,000 to triple in 4 years, compounded annually? So what is our future value?
3,000. Triple.
2,000, yes.
Okay.
So we're using the what? The annual formula. So 3,000 is equal to what? 1,000, 1 plus R to the power what? Time. We don't have R, but we have time, which is 4 years. So we divide both sides by 1,000. So what are we going to have? 3 on this end, and we have our power now. This is where you can apply what you wanted to apply earlier on. The only way we can reach the R is by removing the brackets. So these brackets can only come out if we cancel out the reciprocal. So this is times 1 over 4. And here we have an invisible 1. We're multiplying times 1 over 4. 1 over 4 is as good as what? 0.25. So 3 to the power 0.25. What do we get? Then here you're going to have 1 plus R. So this R will go and subtract 3 to the power 0.25.
1.316.
1.316.
1.316. Okay. So 1.316. So meaning our R is that 1 point what? At 1.6. Is that clear? When you subtract a 1 from there, it will be that 1.6%. Okay, so are we together so far?
Yes, we are.
All right. So, Frida, we go to exercise now on time value of money. Okay, so now let's look at, suppose you invest 10,000. I'm going to easy one first. For single investments. Okay, so I sent you a pamphlet with questions on topical, before we look at the multiple Questions? Okay. Value of money. Congratulations, you just won a small lottery that will pay 5 annual payments within the first. Okay, so any questions before I go? I'm looking for an easier question before we go to the multiple cash flows. Any questions so far? On what we talked about? Are you there?
Yes, we are. None from my end.
The others?
I have a question. On the quarter, the 4 years and then the quarter, where was the quarter coming from?
On the 4 years and the quarter.
Then multiplied by the quarter. The 1/4.
Or 1/4 because the 4 years there. So the only way to, if it was 5 years there, I would have done 1/5, even here 1/5, so that is 0.2. So just a way of getting rid of this. If it was 6 there, 1/6, 1/6. You get?
Okay, so you just follow according to the number that is
Yes, the
given.
number that is there.
Okay.
Okay, let's look at your test question. So yeah, the test here, you have 1,500, an annual interest of 8% compounded semi-annually. How much will you have at the end of 7 years? Okay, so what are we doing here? What are we given? Who wants to try?
I think I can try.
Mm-hmm.
So we are given our present value
Mm-hmm.
of, so basically we're finding future value at the end of 7 years. So
Yes.
we have present value 1,500.
Mm-hmm.
We have ARA, or the interest rate, at 8%. However, this is compounded semi-annually.
Mm-hmm.
So we have to put that into consideration, which is basically 2 to consider.
Mm-hmm.
And then we have T as 7 years.
Mm-hmm.
Okay, so that being said, in our formula of FV, you find that our PV is 1,500. We'll put
What
the whole
formula are we
formula
using?
first.
Mm-hmm.
So we're saying 1 plus ARA over M. Close that. That would be T times M
Mm-hmm.
times T, yes. So when we substitute that, we have 1,500. Open your brackets. That's 1 plus our R, which is 0.08. You divide that by 2, which is semi-annually. You multiply that by 2 times your T, which is 7 years.
Mm-hmm.
Okay, now we can calculate that further. So we have 1 plus 0.04 multiply the power 14.
Okay.
Okay. No values. 1.04. That's to the power 14 times 1,500, which is 2,597.51.
Okay. 2,000.
597.51.
Mm-hmm. 0.51. All right. Interesting. Okay, do we agree with her?
Yes.
Excellent. All right.
Yes.
So we have calculated. Then let's go to another question. Question number 6. Somebody else to try. Question number 7. You want to try question number 7?
So you told us that the effective annual rates formula is 1 plus R over M.
Mm-hmm.
1 plus
The formula is what?
1 plus R over M to the power M
Mm-hmm.
minus 1.
Okay.
Then
So
we look at the question. The question says, what is the effective annual rate, EAR, if the nominal interest rate, so our interest rate there is 12% compounded quarterly. So we're compounding quarterly. So our M is going to be then R is going to be 0.112 over quarterly. So our quarterly is going to be 4, then to the power 4 minus 1.
okay.
Yes. So 0.12 divided by 4 is going to give us 0.3 plus 1. It's going to give us 1.03 to the power 4. It's going to give us 1.1255, then minus 1. 1.1255 minus 1.
Mm-hmm.
Then it's going to give us 0.1255.
Or 12.55%, right?
Yes, sir.
Will be the answer. All right. 12.55%. Okay, so I'm happy so far. It's quite time value is quite wide. So there are now multiple cash flows that are there, then loan amortization and annuities that is remaining. So I think we end here for now. I'll send the test that I need you to do yourselves. I've sent the question on the group. Please, I need those answers before our next class. Should be on tomorrow again.